Hello, in this video we'll be looking more specifically at the exponential functions. Alright, exponential function is defined as let b be any real number, but that number has to be greater than 0 and it cannot be 1, and we'll explain why. Okay, so except 0 and 1, any other real number, then the exponential function f of x is going to be b to the power x, okay, where x is the input and f of x is the output. So b is any real number that is not 1 and that is greater than 0. So of course the domain is all x values and the range is all y values. Alright, so why we avoid b, why we don't want b to be 1 is because if b is 1, anything raised to the power 1 raised to the power anything, if b is 1, no matter if you say 1 to the 100 power, will still be 1. So it will not make any change. That's why we cannot make b to be 1. And then b cannot be 0 because of the same reason too. Okay, and then b cannot be negative. That's why it has to be greater than because if it is negative, it has to be greater than 0. If it is negative, then sometimes you will get a complex number, imaginary number will be part of it, and sometimes you get real number. So that's why we avoid negative number, we avoid 0, and we avoid 1 for b. All right, laws of exponents, which we already learned from algebra. So exponential function uses most of those laws of exponents. So let's review some of them. Okay, the relationship between radical function and exponential function. Let r be any real number or any positive integer. Okay, we already said that b is a real number that is greater than 0 and not 1. So b, the same thing here. If you notice, b is the base here, so we use the b for base, and inside here it is the base too. The root of any fraction is the input, the denominator. So it is the root also here. So that's how I remember that. Root is the denominator, the origin, the independent. So, and if this holds, then this holds also. So when p is not 1, when the number here is not 1, fix any number, so we can put it, square it, make it an exponent for b, or we can find the exponent after we find the square root. Both of them are the same, they are equivalent. Okay. Another rule for b greater than 0, if b of x, b to the power x is equal to b to the power y, then x equals y. So which is saying that if the base of two different powers, if their bases are the same, then their exponent must equal each other. So that's how we solve exponential equation. If you have any exponential, just change the bases to be the same and then set the exponent equal to each other and solve. Alright, when you graph exponential functions, it's what it looks like. See, x will be all real numbers because it goes from all x, but then y has to be positive. Y has to be positive. Okay, keeps going. When the b is whole number positive, when b is a fraction, is a number between 0 and 1, then it goes like that. Okay, it goes like that. All right. Okay, there is a very important exponential function that arises naturally. We call it a natural exponential, which is e. It is a constant, just like pi. Okay, we see this, f of x equals e to the power x. So e is the b now. So, and seeing that it is greater than 1 and is positive, so the graph will look like that. And we use this in a continuous exponential growth or decay. So in a real world application, used a lot in science. Okay? Continuous growth or decay. All right, let's look at examples. 1. Express in simplest radical form. So they want us to leave our answer in radical form. So we cannot use calculator here to simplify this and multiply. No, we have to solve it, work between exponent and radical to find our answer. Okay, let's look at that. All right, so first of all, let's change it to exponent. So we know this is going to be 27 to the power 1/4. Then times, this is going to be 9 is the base to the power 1/3. Right? So let's try to make the base to be the same. Make them have the same base. 27 is something as 3 to the 3rd power. So let's change 27 to 3 to the 3rd power. But then we still keep the exponent there. Times 9 is 3 to the 2nd power. And we still have the exponent there. Okay, so we can multiply the two exponents. So that will be 3 to the 3/4 power times 3 to the 2/3 power. Okay, so now that we have the same base, once we have the same base, we can actually add the exponents. So that will be 3 over 4 plus 2 over 4. Oops, sorry, 2 over 3. So now we need to have them have a common denominator. So if we multiply this by 3 by 3, multiply this by 4 by 4, we're going to get 9 over 12 plus 8 over 12. Okay, remember the rule of fraction. We have to have a common denominator to add fractions. So this is going to be 3 to the power, now that we have them, we have to the power 17. 9 plus 8 is 17. So right here we have that. Now let's try to, what else can we do? Maybe change it back to radical. All right, changing this back to radical is going to be, of course, it's 3 to the power 1/12 times 17. Okay, so then it's going to be, let's write it out here. So it's the 12th root of 3, and the 17, we can put it here. Okay, we can simplify, since we know that if we have an exponent of 12, it can cross out. So we can actually rewrite this as 12. We have 3 to the power 12 times 3 to the power, what is left? It's 5. So because we still, the rule of adding exponents or multiplying powers, if we have two bases the same, we can add their exponents. So this add up to the 17. So we can just simplify it like that. All right, so now we can go further and separate this. So this is going to be 12, cube root of 3. Sorry, this is messy. That's 3 to the power 12 times the cube root of 3 to the power 5. Okay, so this crosses out there, so we have 3. We have 3 left there. We have 3 left here times 12. Okay, 3 times 3 to the power 5th now is going to be 2, 4, 3. And we can leave it like that. So they want our answer to be in radical.